What you see before you is a beautiful analog machine. It's a 1994 American Standard Stratocaster. And I've got it tied actually to an oscilloscope here so we can see its output. And so the output of a guitar is an analog signal. So when I hit one of these strings, it's going to vibrate, and this pickup, which is kind of an electromagnetic device, will sense the moving metal, and with that it'll generate a voltage. So if I hit the low E string, we can see our signal there, which is pretty much the same vibration as what the sound is that we're hearing. So this is an analog signal, and as we can see, it's quite complex actually, right? It's you can see it decays. It's got multiple different kind of frequencies in it. The nice thing about analog is we do have that volume. I can play it very softly, or I can play it very loud and aggressively. And the other nice thing about analog signals is that we can add them together and we can amplify them. We can do stuff with them. Like, so here's me plucking two strings at the same time, and we see it kind of gets a little bit more chaotic. The more I add, if I play all the strings, it gets very chaotic. But the sound still sounds nice to our ears, but this is just the electrical representation that we get. So this is an analog signal, and one of the biggest problems is with analog is you can actually experience noise. So we see this is mostly a clean signal here, but and we can't really get it. But I've noticed sometimes when my phone is very close to the guitar, my phone outputs radio frequency, or I guess it's still radio frequency, but it's outputting waves to communicate to the antenna and the Wi-Fi and all that, and it will actually interfere, and it'll give my guitar a little fuzzy hiss noise. So that's kind of the downfall of analog, is you always have the problem of noise. Whereas digital, it's just 1 or 0. And so though the sander isn't necessarily a digital device, what it does have is this switch on here. And so the switch is off right now. And that was it on. And so the nice thing about a digital signal is that there's not really any ambiguity, meaning we know if it's off or if it's on, right? We know clearly if it's off or on. This, if I say, what frequency is this signal at, and what's the voltage, and how fast is it decaying, and is this an E string or an A string? Do I know? Well, it becomes a much harder problem to analyze, but on and off is very easy, and so that's why computers deal with them. And we can also have mixed signal systems, like this. The soldering iron here has some mixed signals in it. I've got on and off, right? So it's very clearly off right now, and it's on here. But I've also got an analog control where I can adjust the temperature. So those are just a few examples of analog and digital. They're both useful, but obviously for this class we're going to focus on the digital aspect.